Hey there, I'm back again with a new thing I want to show you. You can probably guess what from the title, so I'm just going to roll a clip and let you see it. I hope that last clip was clear, and if it wasn't, I managed to make my game crash by simply spectating someone. Now I would like to explain how that works. But first you need to understand that in programming or computer stuff in general, it's all about numbers, and numbers are very important. They're used everywhere. For example, if you look at this OS bitmap file, you can just see that it's filled with numbers. From metadata to the actual nodes themselves, they're just completely numbers. So I hope you can understand that numbers are very important. Now we got that part. Computers have a limited amount of memory they can use to store stuff including numbers. So we try to limit our numbers to a few bytes. For example, if we take 1 byte, which is 8 bits, we can use these zeros and ones to form 256 different numbers. If you use 2 bytes, we can form 65,536 different numbers. Same for a 32-bit integer, so we call it. You can store 4 billion, and a 64-bit integer, 64 bits being 8 bytes, we can store a lot of different types of numbers. So if we take the 32-bit integer, for example, which is the most common one, that's 4 bytes, we can store 4 billion different combinations of ones and zeros, so that's 4 billion different numbers. So if you look at this file here, we can see that for example, an S byte, which is assigned bytes, you can see here, it's 8 different bits, 1 byte, you probably knew that. You can store 256 different values, so we use that to store values from minus 128 to positive 127. Same for a 16-bit integers from minus 32k to positive 32k, and a 32-bit integer and 64-bit integer. Now you may notice that the positive ends is 1 less than the negative ends, and that has a reason, basically because we have to count for zeros. So if you take a 4-bit integer, that's 4 bits, that's half a byte. We don't work with 4-bit integers because they are half a byte, but in theory you can use them. It goes from minus 8 to positive 7, so the negative numbers would be from minus 1 to minus 8 to minus 1, and the positive numbers would be from 0 to 7. So I hope you now understand that's why positive numbers can be 1 less in size than negative numbers. Now, not everybody thinks about these things. I, for one, didn't actually realize that this could be a problem until I found this bug in OS. So if we start looking at code, we can take the absolute value in code, and if we take the absolute value of the lowest possible 32-bit integer, we can cause some weird behavior. A crash, basically. So as you can see, an int goes from the lowest possible value for an integer is minus 2 billion blah 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 648, and the highest possible one is 1 less. So if you try to take the positive value of this, basically remove the negative sign, we get this number, which is 1 more than a 32-bit integer can actually store. So I have some code because I'm a programmer, I do that kind of stuff. This is an example of the math.abs function, which takes the absolute value. If I run this, we result in 153. So we pass it minus 153, we receive 153 as a result. Now the absolute function is used a lot. For example, in OS, if we hit a node, for example, say we have to hit a node at 15,000 milliseconds, and we hit that 15,100 milliseconds, we can calculate how far we are off. For example, if we execute this code, we can see that the result of this function is 100. Now if I would hit at 200 milliseconds later, we can see that calculates to 200 milliseconds later. If I hit 100 milliseconds too early, we can see this also 100, not negative 100. So we can, since we always have a positive value, we can use this to calculate how much score we would get for a hit, etc. Now, if we do some, if you go back to our negative value, if we take the absolute value of the lowest possible value, we get an error. I don't know if you can read this, you probably can. It says negating the minimum value of a 2's complement number is invalid. I have no idea what that actually means, but I'm guessing it's something with 2 to the power of 31, a negative 2 to the power of 31, that you cannot have that positive. So, if you have had, I think it's algebra in school, I don't know, my English isn't the best, you may realize that if we do this, the time that we hit is at int32.min value plus time that the perfect hit is. If we calculate this, whoa, hold on. If you calculate this, we also get the exception, which basically means that whatever is inside here is this minimum value. And if you don't have algebra, basically we can replace this part with this, and then you can see that we have plus 1500 and hold on. No, this is the other way around. Something like this. No, wait. I can't code, I promise. No, it was like this. Okay. Yeah, something like this. And if you run this, basically it would remove this and remove this. No, remove this because this is positive, that was negative. They cancel each other out. Oh god, what am I doing? Hold on, let's start over. Yeah, this. Okay, that was what it should have been. Something like that, I guess. Whatever. So basically that's what happens. So this is negative, this is positive. They cancel each other out because that's how math works. 1 minus 1 is 0. And it results with the absolute value of the minimum value of a 32-bit. No, the absolute value of the minimum value of a 32-bit integer, which results in a crash. And that's basically what I did in my example previously, in the crashing spectator thing. I was modifying the spectator data that went out of my client on my other PC, and I basically said that I hit very, very early, and that's sort of what made the game crash. It's not exactly as I am describing, but it works sort of in this way. So I hope that was this was an informative video, that maybe you learned something about how computers work, or how some denial of service attacks could work. I hope it was fun to watch. I have a new microphone, which you may have noticed. It probably sounds a bit clearer now, with less noise in the background. I don't have a stand, so I still have to hold it, so it's kind of annoying. But well, I hope this was a fun video. I guess I'll see you next time. Goodbye.